Hello, my name is Daniel Bird, and I'm an IBM Distinguished Engineer working in our cloud platform. I'm going to take a moment to talk about cloud native applications, which are developed using a microservices approach implemented with containers. First, let's use a common definition for the purposes of this presentation about microservices. I'm using a definition that Jason McGee, our IBM Fellow and VP CTO of the cloud platform, has defined. So microservices is an engineering approach focused on decomposing an application into single function modules with well-defined interfaces which are independently deployed and operated by a small team who owns the entire lifecycle of the service. Microservices accelerate delivery by minimizing communication and coordination between people while reducing the scope and risk of change. So fundamentally, microservices have become popular because of their flexibility and support within a cloud environment. So let's take a quick comparison. On the left, we have a monolithic application. Um, this monolithic application has a set of capabilities or components and APIs that are pretty much siloed in their logic. Now, these components all generally share a common data source. In this case, a database where they access independent parts of the data records for the purposes of that application. In this monolith, the entire package, the monolith itself, is packaged as one unit and delivered into an environment. Um, while it's easy to define and distribute, it is quite difficult to maintain over a long period of time because every change that's made to any one component will have an effect on the entire or all components within the application. Um, it also makes for scaling of such an application a little bit more difficult because you have to scale the entire monolith and not individual components of the monolith. And then lastly, the monolithic application in this situation does suffer from the lack of ability to change the architecture of a given component. For example, if you needed to change the structure of the data records, that would be very difficult if a component required that need because other components within the application are also reading the same data. There's no encapsulation and isolation of that data. Now, if we look at a microservices application, it's the same application, the same function, but you can see here that there's a decomposition of the logic. So it's focused around a business logic versus a siloed logic. And each microservice component itself is independently deployed and managed and independently scalable. And they each have their own isolated data. So the data source, the database, whatever persistence that's used for the microservice is self-contained within the usage of that microservices component. And the interactions between the microservices is accomplished via APIs that allow them to be loosely coupled and individually scaled. So now in this microservices approach, each one of the microservice components of the application can be independently scaled as well as independently modified without having an effect on the other. As long as the API contracts are adhered to, you can actually move very quickly and without risk or disruption to the other components. So if we look at the evolution of a microservices architecture, you can see the various components that are used for a given application. Typically on the front you have some sort of an edge proxy or an API gateway in some cases. Some implementations call it the API gateway. And what this does is it provides an interface from public usage into the application. And then that's forwarded into individual microservices within the services tier. Within that services tier, you have some of the public APIs are implemented by a microservice, but then a lot of the communication is done in a private network between the microservices. So interactions between microservices is dynamically routed to the appropriate microservice depending on various routing rules that are surfaced and managed by the service proxy in this case. Service discovery on the right is the registration of the individual services. So services come and go. There's usually multiple instances of a microservice component. Oftentimes there's multiple versions that are running at the same time within the application. And this is necessary for doing A/B testing of various new features so that you're not rolling out a change to everyone, again, reducing risk. But you still want to be able to test it, possibly even test changes in production. Um, Various capabilities like active deploy are used to allow an organization to roll out or deploy new revisions of a microservice without incurring any downtime to the service component itself or the microservice itself. Therefore, no downtime to the services of the application. Um, Other additional componentry in here are things like the container service or cloud services used by the microservices itself. These may be persistent or data services. The container service in this case is a service or platform that provides containers, which are ultimately used as the implementation of our microservices architecture in this case. And as we progress through the rest of this presentation, I'm really going to focus on the use of containers within the microservices architecture. But before we go into more detail about the container usage, let's talk about one of the other aspects, probably one of my favorite aspects about microservices, and that is developing highly resilient microservices. So microservices are intended to allow for easy scale and loosely coupled APIs and evolution of the lifecycle and updates of the microservice itself. So it allows for rapid development. But another key aspect of it is microservices lends itself quite nicely to being resilient to failures. Um, Whenever you have an application, there's a number of different causes for failures. Individual requests can fail due to network or other complications. The code itself that's being implemented could fail. The virtual servers in which the code is running could fail. The physical servers for which the virtualized services are running on could fail as well. If you go even further than that, the actual rack in which the servers are running could fail. And beyond that, even the data centers could have a failure which could impact or ultimately impact your service. So when you're developing a microservice, you have to keep all of these in mind and always think about what could possibly fail in my component. What are the dependencies that my microservice has, and how do I protect against it? How do I avoid any problems, or even more importantly, how do I react and recover from those problems? A great book on this topic is a book by Michael Nygaard called Release It. Highly recommend it. It provides multiple patterns for failures and anti-patterns of failures, as well as various patterns for resolving or avoiding those failures. So with that, I'd like to take a moment to talk about how microservices, or looking at an example of how microservices can be managed within a container-based environment. So containers fit with microservices quite well because of their ease of packaging, distribution, and deployment, and how the lifecycle management of containers, where you're constantly, whenever you make a change, you create a new image and roll out that new image as a new container, generally with zero downtime, actually fits quite nicely with a microservices approach. Amalgam8 is a new project that we have introduced here at IBM. We've made open sourced it as a platform or a microservices platform for developing and managing microservices in a container-based environment. So Amalgam8 is platform and runtime independent. So you can use the framework for developing and managing services and service invocations between microservices developed in any runtime and any platform. Amalgam8 has multi-tenancy built in. So you can have multiple tenants managed within the same control plane. And ultimately, we believe it shortens the development lifecycle because it, it simplifies the way in which services are registered through an automatic registration mechanism, how they're load balanced, and how you do various tasks such as red-black deployments as well as canary testing. All of this is done through Amalgam8. So let's take a look at the architecture of Amalgam8. Amalgam8 is made up of a control plane. Remember, it's a multi-tenant control plane and one or more tenant spaces. Key aspect of the Amalgam8 control plane is that it has an API layer, a CLI as well, for programmatically defining the services and the routing rules for those services and the testing for those services. So that's done through the control plane. And then in the tenant space, the key aspect of the tenant space is the fact that you have what are shown here in the black bars, the sidecar implementation. The sidecar is an Nginx proxy that is associated with each and every one of your microservices to make it incredibly resilient, reduce the blast radius as well, so that if any one of them goes down or any one of the microservice components go down, its effect is limited to just that one implementation, not all the others. The proxies themselves, or the sidecars in this case, get their routing rules programmatically through a messaging system managed by the control plane, as well as the rules and definitions defined within the control plane. So as services come and go, as routes get defined, as definitions get defined, those are defined in the control plane and then propagated down into the tenant space. Amalgam8 is available at amalgam8.io, or you can visit github.com/amalgam8 to find more information. And what I'm going to do now is I'm going to switch over and I'm going to show you a quick demonstration of how you can manage microservices within using containers, in this case Docker, in your local environment using Amalgam8 as the microservices fabric. Let me switch over to my web browser. So this is the amalgam8.io site. And the site itself has a lot of information about what is Amalgam8 and why you would use it, so that you can read this at your leisure. But what I'm going to do is I'm going to switch over and go to the project on GitHub. And in this project, you have an examples repository. The examples repository is very nice because it has two examples in it, Hello World and Book Info. And it has setups for localhost deployment using Docker. You can do Kubernetes, you can do Marathon and Mesos. And it also has examples of doing cloud deployments using IBM Bluemix and the Google Compute Cloud. One thing to note when you're deploying this Amalgam8 into the IBM Bluemix, several of the capabilities from Amalgam8 were derived from services in IBM Bluemix. And deploying into IBM Bluemix, you actually have to you don't have to deploy as much of the control plane yourself. Much of it is available inherently as services in Bluemix. So that's something else to keep in mind when you're developing these and going through the examples. Another note here is that the examples provide a great learning device. If you don't know containers, you haven't learned much about Docker or Kubernetes or Mesos, these are a great set of examples to go through, even to learn the technologies and to leverage them. So highly recommend them if you want to have that learning experience. But what we're going to do is we're going to take a look at the book info example. It's a very simple example that has a gateway, product page, several a review page, and a details page. Now the reviews have 3 versions available in this example. V1 has no stars for their rating reviews. Version 2 has the use of black stars, and version 3 has red stars. So that's basically how it's set up. Let's switch over and configure or start up our book info example. So we're going to move over to my terminal, and I already have the tools installed as well as Amalgam8, which are described in the GitHub project and how to set those up. So the first thing I'm going to do, I've already cloned the repository here, the examples. If I take a look, if I do a docker ps, you can see here that the Amalgam8 control plane has been deployed already. So I've already done that ahead of time with the gateway and Kibana and the controller and the registry. So what I can do now is start developing and deploying the example. So in this case, the book info. The example uses Docker Compose. So we're going to do a Docker Compose with the book info YAML, which is our compose file, and we're just going to do an up with -d. And what this is doing is it's starting up the example. We can do a docker ps, and we can see that it is up and running now with the various instances. So with docker details v1, v2, the reviews, v2, v1 and v3. So we have all the instances up and running. Now if we take a look at the Amalgam8, it has a command line utility, A8CTL, and we can do service-list, and this will list out all the services that have been created. These are automatically registered when they are started up within Docker. You can see here we've got multiple versions defined, so all of them have a version 1, and reviews has version 1, 2, as well as version 3. So we have 3 versions of reviews currently deployed. Again, Amalgam8 really helps to manage multiple versions of microservices across multiple tenants. So okay, now that we've got that up and running, we could take a look at our route list to see all the routes that are defined. And you can see here each of the services are defined and what the default version is. So you can see version 1 of each, version 3 of the other. What I'm going to do is I'm going to reset. Let's go back to route set, and we're going to set reviews, the default, back to v1 for now. So that sets the reviews to v1. We look at the route list, everything's at v1. So now we can switch over to our web page, and I'm going to go to our website, and the website here is going to go to the proxy. Actually, let me get this so you can see the top here. So I'm going to go to the product page, which goes through localhost 3200, which is where the gateway, our service proxy, is running. Our service proxy product page is the name of the service. Product page is the command within the service. So you can see here it has book details. Let me slip this down just a little bit to see it better. We can see, I'm going to sign out for the moment, and we can see that right now there's version 1 and it shows no stars over here in the reviews. What I am going to do now is I'm going to do some A/B testing. So in the A/B testing, I want to make sure that when I log in as Dan, I see the version 2 of the reviews. So let's put the Amalgam8 control, and let's do a route set on reviews. The default will continue to be v1, but we're going to set a selector. With the selector, we're going to have v2 is going to be our selection, and we're going to do it based on the user, where the user name is Dan. And if we take a look at the route list again, we'll see v2 user equals Dan. So now if we go back to the web page and refresh, it still shows nothing. If I sign in as Frank, you can see that it still shows no stars. I'm going to sign out and sign in as Dan, and you can see here I get black stars now, because it's doing selections based on the user. So I, as Dan, am the only one that are going to see this version of the microservice, the reviews microservices. Okay, now with that in place, we may want to do further testing. So if we take a look at our um, Amalgam8 examples, you can see in the examples, I'm going to scroll down a little bit here. You can walk through all these same examples that I'm doing. But what we're going to try now is some resilience testing, and it's using a technology codenamed Gremlin for doing that. Now, Gremlin allows you to inject various conditions. Like in this case, we can inject a delay um, in our request. Now, in the delay, you do this using a rule set, and you can define a source, which will be the reviews, and a destination being the rating. So when we go from the reviews to the ratings, we're going to look for a user and inject a delay. So I'm going to go ahead and copy this string and switch over to my terminal. Um, I'm going to go ahead and set or change the name. Instead of Jason, I'll make it Dan again. And what we have here is the delay is 7 seconds. So if we look at our rule list, we can have a number of different rules. So what we have is a rule from source to destination, looking at the header information. If the user is Dan, we're going to inject it. The delay probability is 100%, so it's always going to happen a delay of 7 seconds. So let's take a look at the effect of that. So if we go back to the application and I sign out and sign in as Frank, see it returns exactly as expected. If I go in as Dan and sign in, you'll notice that it's taking much longer this time. And again, it's taking 7 seconds, and in this case, the actual application failed because it took too long. So now with Gremlin, you can actually do some interesting things as far as testing it. You can do some systematic testing by running a script. Now, what this script will allow you to do is really test for various conditions, and it will give you a report on where it found the problems. The example has what's called a gremlin recipe. It's a file that will execute a test for you and then print out the result sets coming from the log entries that are getting written out. So let's go ahead and run that recipe. So we're going to run a recipe, and again, the user is going to be Dan. If we run this, what it's going to do is it's going to hold right here for the injection test. So what we're going to do is we're going to go back to our application, and we're just going to refresh this page. So we'll wait for the failure, and what's going to happen here is the system's going to record or analyze the logs to figure out where have we hit a problem in the interactions of our microservices. So let's go back to the terminal, and then we'll hit enter to allow it to go through and do the validation phase. So now it's validating the results of that execution, and we can see here that the actual assertions within the gremlin test have passed for the gateway to the product page, gateway HTTP status passed, but we have a failure on the review, and this is going from the product page to the reviews. We get an unexpected $4.99. So this is a nice way of doing some testing and validation of your failure cases within your application. So instead of trying to find some other way to test for failure conditions, you can use Amalgam8 and Gremlin to inject failures into your processing, and then you can test for those failures. And that's exactly what this platform is meant to allow you to do, as well as run production level microservices on any platform for any language. So now let's make another change here. So we're going to come in and we're going to clear out our rules, and we're going to reset our routes for our review. So we're going to do a route set for reviews, and we're going to set the default back to V1, and we're going to remove that selector. So now we should see in our control, if we look at the route list, it should just be all V1. If we switch over to our page and we do a refresh, and we're back again, I'm signed in as Dan, and I'm not seeing any stars. Now, another feature of Amalgam8 is the ability to deliver changes into this environment with zero downtime. So we're going to do that right now. We're going to use Amalgam8, and we're going to do a traffic start, and we're going to do this with reviews. And this time we're going to go from version 1 to version 3. So now you can see a status as transfer starting for reviews, diverting 10% of traffic from V1 to V3. If we go to our web browser and do a refresh, and we keep on refreshing, what you're going to see is the red stars are going to pop in. So remember, only 10% of the traffic is going to V3, whereas 90% is going to V1. So you should only see the red stars occasionally. And that's exactly what we're seeing here. So now what we can do is we can bump up, since it's working the way we expect it, we can do a traffic step for reviews. And what this is going to do is it's going to bump up to 20%. So now when we refresh, we should see it hit the red stars a bit more frequently now, because it's now 20% of the workload versus 10%. And you can keep doing this, increasing a little bit at a time. So you can do a step for reviews, but you can put in an amount, and this case we'll do 50%. So it'll pump it up to 50%. So when we're looking, it should be roughly half the time should be red stars and half will be non-red stars. All right. Now, if there was a problem, you could do an abort. So you could quickly abort out and divert all the traffic. So if I do a help here, you'll see that you have traffic start, step, and abort. So the abort will allow you to completely remove traffic and go right back to version 1. But what we're going to do is we're going to push it all the way to the end because we're happy, we like the red stars. So I'm going to go ahead and do a step, and this will be for reviews, and we're going to go ahead and push it all the way to 100. So now all the traffic should be going to V3, none of the traffic should be going to V1. And if we take a look at my browser and start refreshing, it should only be red stars, and that's exactly what we're seeing. And lastly, if we take a look here and look at the route list, we will see everything's on V1 except for reviews is now on V3. So I thank you for taking some time to listen to a quick intro into microservices using containers, as well as a quick demo of how you can utilize Amalgam8 as your polyglot microservices framework that allows you to programmatically define and manage microservices within a microservices architecture developed using containers, and allow you to do controlled failure testing of those microservices as you're making requests between them. I hope you enjoyed this, and if you have any questions, especially around Amalgam8, you can go to our Slack channel. The Slack channel is available. If you take a look at the Amalgam8 site, you can find the link to the Slack channel at the bottom of the page. Thank you for watching, and have a good day.